Stick with that. They won. All right. So last class, we talked about the interior angle sum theorem, or the triangle angle sum theorem. Today, we're not doing inductive logic. This is a super old notes. Let me get rid of that. Yeah, that was ages ago. Clear. All right. Today, we are continuing, and we only have a little tiny bit left of 2.3 to knock out. Yes, sir? We did not, because we spoke about them. 2.8 and 9 says that if lines are parallel and a transversal is perpendicular to one of them, then it's perpendicular to all. Like they're all 90 degrees. That was one of them, and I'm trying to remember the other theorem. 2.9, or that was 2.9, I'm sorry. 2.8 says if A is parallel to B and B is parallel to C, then A is parallel to C. I wrote them on the board, we talked about them, we did not write them down. Okay, all right. So, jumping in today, last class we talked about the interior angles of a triangle. And we know that all three interior angles add up to, one more time? 20. What else is there on a triangle if not, exterior. Oh my gosh, we have exterior angles. So, here we go. Exterior angle. So, exterior angles and triangles. We are still continuing on 2.3, and this is just the second half. The first part was the interior angles, now we're on the exteriors. Awesome. First of all, we're going to draw a picture to make sense of, and just to get a little bit of practice with. If I draw this triangle, we can all agree that there are three interior angles. Okay. There are exterior angles. They're not the ones that Adeline just identified, but that's okay. When we do this, we're going to sketch a bunch of exterior angles, and we'll just make sure we color them, and then we'll get a theorem with them. Okay. I don't really care what these are. I don't even care to name them. If I wanted to, could I start at this bottom line and go left to right, just like this, and extend it out a little bit? Yeah. So check it out. If I'm going this way, and I'll even change color for it. If I'm going this direction, I could start here and I could extend it out. Did I just form a new angle? Like right here specifically. That is now on the inside or outside of that triangle. Check it out. We have an exterior angle right here. Here's one of them. Now, we could get a bunch of them through our triangle, and just so we can see and prepare for it, notice I went here and through that point. If I now start at this point and go back through it, I get another exterior angle. Here's angle 2 for us. Could I do the same thing here? And here's the big part. We need to be able to see where these angles are getting formed, because I think that realistically I have two choices. I'm going to obviously put the third angle here somewhere. It could go on this side or this side. Left of that extra line or right of that extra line. Which one do you think it is? Right. It's the right. It's always formed between that extension and the side of the triangle. This is my exterior angle right here. Okay, so I'll label that 3. Here's my challenge for you. Exact same picture. Can you find me 3 more exterior angles? You might have to add some stuff to it, just like I did. We started with a triangle, and I added these extensions. Can you do the same thing and find me 3 new exterior angles? Yeah. That's what I want you to do real quick for me. So we should have a total of 6 different exterior angles. I see where you're coming from. You get 3 more? Kind of. Can you show me 4, 5, and 6? I don't know where you put it. He said find 3 more. 9. No, is it okay if we can? I know why I have 9. Not quite. This is good. These are good. That's wrong. Yep, correct. All right. So as we're looking at it, maybe there's an easier way. Okay, if we go the other way, and I'll switch colors again. Instead of going, would you guys agree that when I went around my triangle just now, I went counterclockwise? Yeah. Okay, could I go clockwise instead? Yeah, I think so. I'll start here and extend out. Did I just form a new exterior angle? Now, there's a natural choice. It could either be here or here. Top one. Because that angle is always formed between that extension and the triangle. Could I do the same thing here? And here's 5. And same thing here. Here's 6. I don't really care about your numbers right now, just so you know. What I really want you to pay attention to, because if you're going to make a mistake of misidentifying it, notice, this is not the exterior between them. That's not, and that's not up here. Okay, the other ones are. Now it turns out that we is going to feel like a completely unrelated question. We live in Alaska, correct? Are we in remote Alaska? I would say we are remote. We're not in the bush, which is another word you might use. Although I think that we are in the bush, we're just in the bougie bush, realistically. Like, we have money here that's very different than a lot of other places in Alaska. I think we are fairly remote. Okay, can we all agree with that? Or can we think of a more remote place than this? Kodiak is less remote than we are. Cold Bay? So maybe, Cold Bay, same idea, right? We're actually further away. But King Cove, that's the same idea. Okay, can we just agree that we are in remote Alaska?
Yeah.
Okay, follow up. What do I mean by remote?
Isolated.
Isolated, far away from like the big hub, right? So Kodiak is, I would say it's a little bit remote realistically, but it's not far from Kodiak to Anchorage. It is a long way from here to Anchorage. We are remote. We are removed from the rest of it. The reason that I'm addressing that is if we can understand this picture, we will make sense of a theorem here. So right off the bat, this one I can never decide how to write it. I'm going to write down the exterior angle theorem. Okay. Knowing that it's called the exterior angle theorem, is it silly for us to call this theorem 2.12 and then immediately say that this is the exterior angle theorem? 2.12, exterior triangle angle theorem. And what I'm getting at is this super redundant or is it okay? Because it is theorem 2.12, but it's also the exterior triangle angle theorem. It feels weird to write theorem twice. All right, we'll be all right. We're going to try it with a picture. And if the picture doesn't make sense, I lied. We're going to do it with words first, and then we'll do it with a picture. So here we go. If we have an exterior angle, bless you, of a triangle, bless you. So we'll draw this picture from this statement here in a second. If we have an exterior angle of a triangle, then its measure is the sum of its two, and I'm going to sneak in a vocab here and we're going to make sense of it. If we have an exterior angle of a triangle, then its measure is the sum of its two remote interior angles. Klein, go get me a drink. And check to see if the door is locked out there for me while you're at it. Okay. Right off the bat, I don't normally give definitions inside of a theorem, but I think here it makes sense. Remote in our sense is removed from. That's it. Okay, so can we make a picture out of this? And let me rephrase that. We're going to make a picture out of this. I need a triangle and at least one what? One, so what type of angle? Exterior. I need at least one exterior angle. So I'm going to label these 1, 2, 3, and 4. Cool. All right. This is like my whole if statement. If we have an exterior angle of a triangle, we do, then we just got to make sense of this. This is going to imply something for us, and we're going to make sense of this picture. Is there an angle that is close to the exterior? So something that's nearby angle 1. Angle 2 is close, right? Everybody agrees with that. Are there two that are further away from it, like maybe more remote? Is it 4 and 3? Yeah. And according to this theorem, it says that the measure of angle 1 equals what? So the sum of the two remote interior angles. if angle 1 is my exterior, what are the two angles on the inside of my triangle that are kind of far away? Measure angle 3 plus the measure of angle 4. Okay, this is the picture of that theorem. If I give you this, here it is. Now, here's the fun part that everybody always needs practice with. I didn't scoff at you. What did I just indicate we're going to do? We're going to prove it, PF, right? What are we trying to show? And we're just going to use this picture because we already have it. Show that 1 is the same as 3 and 4. So I'm going to start it off. We get triangle with angles. And we all have it. Theoretically, we should all have this picture. And that's all we're given. I'm going to give you and your neighbors the next 2 minutes to try to logic through this proof. This is a pretty nice proof to do. You need to end with angle 1 equal to 3 plus 4. I'm going to give us 2 minutes. I'm then going to call on random people, and we'll just take random steps and hopefully find our way through it. Cool. Discuss with your neighbors, how do we get from just this to this? 2 minutes, starting right meow. The hardest part of every proof is just deciding where to start. Always. Now, when you're trying to logic through a proof, which it's good to think it out first, I try to. I can't always do it. But I know that I need all of this stuff in my proof somewhere. So if we're ever like really, really struggling to start, if there's something that you guarantee is going to be true and you can justify it, that is a good thing to write down. Is there anything true about this picture that you guarantee is true?
4 and 2 are
2 plus 3 plus 4 equals 1.
If we take these three angles, angle 2 plus angle 3 plus angle 4, it's the three angles of a triangle, and they add up to what?
180.
So that's true. That's the triangle sum theorem. Let's write it down. Whether or not we use it isn't part of my concern yet. Realistically, in this class especially, if you write down something you know is true, there's a 90-something% chance that we're going to use it. So I know that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Remember, we did talk about a shorthand for how you can write that. It's up to you. This is, what's that? How do we know that? Triangle, angle, sum. When we use this Greek letter sigma to represent the sum. You can write sum. You can write triangle and the word angle like. You write whatever you want. If it's a new shorthand that you've made up, I would make sure that you're prepared to answer what it is. But cool. I agree with that. Now, a different group, Gian and Sunny, I heard you guys identify something else was true. What did your proof start with? Your B is different. That's okay.
Measure of angle 2 plus measure of angle 1 equals 180.
Okay, I think that this is true. My challenge, rather than just asking Sunny and Gian to do it, how do we know that's true?
linear pair.
It's a linear pair. And I appreciate that you guys like raise hands and volunteer and stuff. If I don't very clearly have a way that I'm picking somebody random, we're cool to just shout it out, okay? Like, I appreciate it, but I don't do a ton of that. Huh. Well, this is going to feel silly, but just forget about everything here. What does 180 equal to?
A straight line.
So that's one way to answer it. You're correct. Do you agree that if I said 180 equals 180, that's true?
Yeah.
And it feels silly that you would even say it, but it's obviously true, right? Or, gosh, these both have a 180. If they're both 180, can we just set them equal? Now, I'm really substituting, is what I'm doing. But let's check it. I'm going to write on step D, I'll rewrite this one, the measure of angle 2 plus the measure of angle 1. And we already know that's equal to 180. But there's another way to write 180. Instead of that, measure of angle 2 plus a measure of angle 3 plus a measure of angle 4. And why am I allowed to write that step? So they both equal to 180, and I literally just took this 180 and I plugged this in for it. I substituted. Okay. If your proof sense is tingling now, we're close. If it's not yet, notice what we're trying to get to. I need angle 1 is equal to 3 and 4 if we have this line. If only there were properties of equality that said if you have an equation, something like this with an equal sign, if we do the same thing to each side, it's okay. What should I subtract?
Measure of angle.
Let's subtract the measure of angle 2 from each side. That's a subtractive property of equality. And let's just see what's left. If I subtract the measure of angle 2 from the left, I get measure of angle 1. And if I subtract measure of angle 2 from this side, I get measure of angle 2 plus the, just kidding, we just subtracted it. Measure of angle 3 plus the measure of angle 4. And why was I allowed to do that? Subtraction. Notice, here's why I go so far on my shorthand. What's the very last thing we need to do? A box with a square or QED. All of a sudden, just by writing down these things that you guys know are true, we can get our proof finished. If you had taken any step at all, there's a good chance it would have been one of these two, and you're already halfway there. Just trying it and writing down something you know is always a good first approach. Does this proof seem super crazy hard? In general, are proofs getting easier? Just give me a yes or a no. Okay, that's fair. All right, I want one little practice problem with these, and you can sketch it if you'd like. Let me look at the homework that I'm going to give you guys later. Oh, I like this problem. We're going to find a better one than that. You guys do 12. You know what? I'll just make one up. Nope, we got it. I want you guys, we'll call this an example, and this is just a quick one. I want you guys to find for me, let's see, focus. That didn't focus at all. All right, we're going to do number 7. I will zoom in on it. You guys can have this as an example. Find x is the name of the example that I would give. We're going to look at number 7. I want you to find me x on this one. There's a couple ways that we can do it. I will give you guys a minute or two. Talk with each other. We're doing this problem right here. Number 7, you can do an example in your notes. Example, find x. That's it. Solve x to this problem. Right here. Cool. Show some work, because I bet you do have it. This theoretically should be like a 30-second problem, maybe 45 if you need to do some longhand addition. Are you looking at number 7?
It's not, it's just
46 degrees and 70, sorry, 57. Is this exterior? Is this the exterior angle? And we have 2 remote interiors. Which angles inside the triangle? So what do we know? What's that last term say? The exterior angle is equal to the sum of the angles.
Am I just off my dice?
Would you guys get through the last one? What?
Does that make sense or not?
180 minus 106.
180 minus 3 is 78.
Okay, so walk me through it, because I have a feeling.
7.
Yep, so can you, I don't see any numbers, okay, can you tell me what you did to get one of those? Perfect. Okay. That's it. Is there another way to do it? So there definitely is. Okay, so checking it out, coming back together here. 2 ways to think about this problem. Do we have an exterior angle right here?
No. Oh,
We
yes.
do, it's x, right? That's exterior. Are there 2 remote interiors?
Yes.
Okay, that are associated with the same angle. So I know that this angle is just what with those 2? Add them up. Okay, I think we can add them up. 46 plus 50 is 96 plus 7 is 103.
Yep.
Okay, that is one way to do the problem. Is that the only way to do the problem? Can you tell me another way to do it?
Figure out the last angle.
Okay, so check it out. That is, I would consider the good way to do this problem. It is not the only way. I try not to just show you guys a bunch of different ways to do any particular problem, because I think that if you have too many options, it can make it harder. However, these ideas link so closely together that I just want to make sure it's clear. Here it is. On this problem, conceivably, what do I know? This and this and this add up to.
180.
So let's see, this is 3 short and that's 14 short. So this is what here? 77 degrees. And we just said that these 3 add up to 180. Once that's 77, what do these add up to? 180. So we could get x equals 103 doing that. Or, if you're comfortable with the fact that a theorem exists, I know that this angle right here, measure of x, and I hate that we're doing it this way, but that's what it's written as, equals, what are the two remote interior angles?
460.
So whatever order they come in doesn't matter.
No.
We get 103 the same. Whether you want to think about all three of them and then use linear pair, or just use this theorem directly, we get the same answer right away. Cool.
Do we have to do the whole, like, given and all that?
Nope. The only time you ever need given and show, it'll very explicitly say prove this or show this. If it doesn't say prove and given, it's not a proof. Okay. So for tonight, we get 13 solid minutes here. And let's see what we get to add.
Or is it gonna be the same page or?
It is not, because the assignment that was due today was from Thursday when I thought I was going to be gone. So that's 2.2, and I'm going to change this. Did I already change it? Okay, the one from yesterday, or over the weekend, last Thursday really. I'm going to say it's due 9:30, because we get another one that's due today as well, or tomorrow. Okay, 9:29, and we'll come back to this part here in a second. Your homework tonight, homework 2, whoa, I'm all goofed up. Because I went to third hour, all right. Let me go to third hour real quick. Weird. It's not the 26th, but that's okay. All right, here we go. There was your homework from the 26th, and then we'll go 9:29 today. And we'll get right into the homework. Homework tonight, I want you to do, additionally, 2.3, which you will find on page 91. And I want you guys to do problems 12, 15, and 18 through 27. Cool. Just a reminder, tomorrow in class, which ones am I collecting? Both. That is not due the 27th. That is due the 30th.
And the other one, is it just problem 8?
And I'll even fix this one. It was just 9.
Oh,
You can do 8 if that's a proof you want. 8 and 9, and then 12 through 25. If you've already done proof, don't do another one. You only have to do one total proof. Okay, both of these will be due on tomorrow at the start of class. If you had anything done last week, you're probably close to done with this one, theoretically. Cool. 10 solid minutes. Give me 10 minutes of work, and I'll try to continue giving you guys homework. I'm ready to start tomorrow's lesson if need be. Klein. Oh, I thought you were sleeping. I'm sorry. Were you sleeping? Okay.